It is very difficult to assess a machine's performance without good estimates of the forces sustained by its bearings, cams and gears. It is virtually impossible to size motors without good estimates of torque. Typically, servo manufacturers will provide calculations to estimate torques and forces required for linear mechanical systems. By linear, I mean systems which have fixed inertias attached to the motor's output shaft, which can be readily calculated using the simple formula T equals J alpha. Unfortunately, mechanisms typically have a non-linear relation between their inputs and outputs. The traditional notion of J as a fixed term in the above equation disappears. It becomes a much more complex function, its complexity depending on the number of degrees of freedom, and the terms in it depending not just on acceleration, but non-linear functions of velocity. It is difficult to calculate this function generally. MD Pro calculates the torques and forces directly from the individual part inertias. Dyads are composable structures, usually having two parts and three joints. One joint links the two parts together, and the remaining two joints connect each part onto something else. Accelerations and velocities of dyad parts can be calculated readily from the geometric intersection equations required to solve the dyad positions. If we know the accelerations and velocities of the constituent parts, then we can calculate the joint forces and torques. This is because we can calculate the inertial forces acting on the external bodies accelerating it. So enough theory. How do you generate force data in MD Pro? Well, it's quite simple really, you just turn them on. In this example I am designing a folding table, and I want to know the joint forces and torques required to move a table leaf. I have already imported a solid part into MD Pro from SolidWorks. The leaf will be connected to the coupler of the forebar. First, I must turn on force calculation. The force and torque size vectors can be controlled using these spin boxes. If I want to move the motor to a different joint, then I need to configure the power allocation in the kinematic tree. If I select the dyad I want to change and right click on it, I can open the power configuration dialog. Now I can select the joint that I want the motor to power. If I want to plot out the motor torque, for example, then I need to add a force function block. Now I can link a joint's force or torque, if it is powered, to a plot and view its torque over one complete cycle. So add a plot function and connect up the force function block to the plot function block to view the force. That completes a very quick introduction to forces. I will do another more advanced force video in the future. The next video in the series explains how to use patterns.